Okay, it's 4 p.m., so let's go ahead and get started. Good afternoon, everybody. How's everybody doing today? Good, good. Yeah. Weather's warming up, so that's good. So unfortunately, my desk is right next to the window, so you can see one kind of right here on this side, but then there's also one right behind my computer. So it's actually kind of warm in this corner. Sometimes or actually yesterday, it got so hot that I was, my hand was sweating when I was trying to write on the iPad. That wasn't comfortable. Right? Oh man, yeah, sorry to hear that, Johnny. Yeah, it's tough. It's interesting, like everyone kind of has a different way of handling exams. Yeah, it's we actually just had a faculty meeting discussing it today, and yeah, there's no good way to go about it. I'll say that kind of from everyone's perspective involved, because my feeling is that everyone's kind of dealing with a lot of stuff right now, so I try to be I try to like maximize my flexibility, but at the same time that kind of unoptimizes things for other stuff. So it's challenging, and I think it's especially hard on you guys too. So I think I'm pretty glad that we kind of decide not to do any more exams, because I think ultimately these Ansys activities are going to be more valuable for you guys, and exams are just not easy to do right now in this time. Oscar, your question. I can't answer that. I can't speak for everyone, but a lot of faculty that I know that they do really care. I think everyone's just trying to figure out kind of what's the best thing to do, and I think it's a really tough question in this time. So I think a lot of them do have compassion. It's just everyone kind of expresses it in a different way. I think I'll say that. Okay. Oh yeah. Right. So you guys probably got the email about the credit or no credit thing. So I haven't had a chance to read that in detail, but from what I understand, the school is going to let you basically after the class is done, basically after all the grades are in, if you want to basically change the class from a letter grade to credit, no credit. So I actually forgot to check that out today. That was something I was going to read, but if that's something that you want to discuss regarding this class, if you're concerned about your grade, I'm always happy to do that. So you can either email me, and then we can set up a private Zoom meeting where we can talk about it kind of in private. So if that's something that you're interested in doing regarding your grade, or you're just concerned about your grade in general, then definitely let me know, and then we can set something up to talk about that. Okay. Okay. So the plan for today is to do our next Ansys activity. So today Ansys activity 4 was due. So that was our last time we picked up Ansys, we were doing dynamics. So today we're doing something that's going to be really important for a lot of your guys' projects, and that's we're going to explore different element types. So kind of building off kind of what we talked about Tuesday, what you'll see today, there's kind of specialized element types that you can use in Ansys that can really dramatically cut the cost of your simulation if you have certain geometrical features. Okay. Okay. So let's go ahead and get started. So if you, I'm going to talk a bit for the first, 5-10 minutes. So if you want to start up Ansys, then you should go ahead and do that. So the activity today, it's a little bit lengthy, so it's going to take us a little bit of time. So it might spill over into next Tuesday. So if it takes us, if we don't finish today, then we can pick it up next Tuesday, and I'm, that's totally okay. Okay. So let me share my screen. Okay. Let me minimize you guys' faces or lack thereof. Okay, so here's the PDF that's uploaded on Titanium right now. So you should, be able to download this. I've uploaded a CAD file that we're going to use for the activity today too. Okay. So this first part here kind of just introduces the idea of shell and beam elements, which are kind of the theme for today, and why you would want to use them. And then from there we'll launch into the activity. Okay. Okay, so to start off, let me kind of go over this first paragraph here. So we talk a lot about the kinds of elements that you should use in your finite element analysis. So for most cases or for all the cases that we've talked about so far, for all the 3D simulations, we've basically only had 2 options. So we've had tetrahedrons, and we also had hexahedrons. Okay. So I've drawn those many times, so you know what they look like. And on Tuesday we kind of went over the different properties of each. Okay. So one thing I haven't really talked about is that these elements, they both belong to a certain class of element types, and they're called solid type elements. Okay? And the reason they're called solid type elements is because they're basically three-dimensional solid objects. So a tetrahedron is basically a four-sided pyramid, and your hexahedron is just a brick, basically, like a six-sided box. So these work great. For a lot of the cases that we've seen where basically the geometry has, roughly the same length scales in each of the three coordinates. Because these are three-dimensional objects, it kind of helps if your object is also, relatively three-dimensional. And what I mean by that is that there has some appreciable length in the X, Y, and Z directions. But for a lot of engineering situations, this is not always the case. So for a lot of engineering geometries, you might have geometries that are either thin, if you use some kind of plate to model it, or they're slender. Okay? And so what's unique about these kinds of geometries is that one or more of the lengths of your model is significantly less than the other one. Okay? Like if you think of a thin plate, you can think of the kind of the width and kind of the height of the plate. But when you look at the thickness of the plate, it's actually really, really small compared to the length and the width. Okay? So it turns out, for these kinds of special geometries, which happen quite a lot in the kind of the work that we do, solid elements will really struggle with these. Okay? So to kind of give you an example, I have kind of two cases here. Okay? So on the left right here, I've given you a case where we have a relatively thick member, so it kind of has the same dimensions in both dimensions. This is a 2D case, right? And so because of that, we're able to pack a really good mesh density in here. So we have, let's see, 1, 2, 3, 4, 5, 6 elements across, and then we have like 10 elements through the thickness. So whenever you have kind of multiple elements through your length, that's always going to be a good thing, because that's going to lead to really accurate results. Okay? But on the right here, we kind of have the opposite case where our geometry is really thin. So while we're able to get 5 elements across from going from left to right, when we go from up to down, we can see that we only have just 1 element thickness there. Okay? So usually, this is a pretty big indicator. So this is something that typically people look at when they look at your meshes. So if you have parts of your model where you only have 1 element thick, this is usually a bad thing, because this usually leads to some pretty poor accuracy. Okay? And the reason for that is because you can imagine if this is kind of the extremities of your model, you're basically going to be applying boundary conditions on the upper and the bottom one. So even if you don't do it explicitly with the load or constraint, you're kind of doing it implicitly too, because if you don't apply any kind of load or constraint on the top and the bottom here, then what's kind of implicitly assumed is that those surfaces are going to be stress-free. So that means it's basically a pressure value of 0. Okay? So when you have 2 places right here where you're applying a boundary condition on the top and the bottom, there's really no room for this to kind of vary or to kind of be free. So that's why when you have kind of situations where you have only 1 element through the thickness, this can lead to pretty poor results. Okay. So we know that having only 1 element through the thickness is pretty bad. But a lot of times you can't really help it, because the geometries that you're kind of given in your model, either you use some kind of plate or you use some kind of thin, slender rods in your model. It's so thin that it's if you try to refine the mesh enough to pack more elements in there, you end up with a mesh that's unreasonably expensive. Especially if you're using the kind of the student version or the academic version of Ansys, you'll quickly run up your element count or your node count, and then Ansys won't even try to solve your problem. Okay? So for those of you who are working with these kinds of geometries in your projects and you've been kind of struggling to mesh, I've spoken to a few of you, you'll notice that it's a big pain to try to deal with these thin and slender geometries. So the good thing is, like, you guys, we're not the first ones to discover this. So people have been struggling with this in finite elements for many years. So specialized element types have been created for these purposes. Okay? And those element types are shell and beam elements. Okay? And so what's special about these element types is that they're really specialized for these kinds of geometries, where a shell, if you think of like a shell that's like on a snail or something. So a shell is something that's really thin, but it's really wide and really long. So it basically has only 1 dimension that's really thin or really small compared to the other ones. So that's essentially going to be a 2D structure. So we can instead of trying to put a 3D solid element there, we can instead replace it with a specialized 2D element, which is our shell element. Okay? And then the other specialized element type that we'll go over are beam elements. So beams are, just like as the name says, are, elements that are, are really, really long in one dimension, but the other two dimensions are relatively really small. So just like a structural beam, as if, you would imagine, that would be holding up a building. So these type of geometries, we can actually replace them with 1D elements, which is great because 1D elements are super cheap compared to 2D and 3D elements. Okay? And if you do that, then that's going to cut down the cost of your simulation pretty significantly, and allow you to mesh things a lot more efficiently. Okay? And so, we won't really get into the mathematics behind shell and beam elements because that's, a whole 2 chapters in the textbook. But I'll just give you kind of the upshot about why these elements are special compared to our solid type elements. And the reason for that is, in addition to computing displacements, which is what the solid elements do, these shell and beam elements also compute rotations at the nodes in on these elements. So what that does is, per node, you're basically computing, 3 elements of rotation in addition to displacement. So it's a bit more expensive, but the amount of cost that you save by not having to refine the mesh there is significantly more than, than the really modest increase that you get from these rotations. Okay? And these rotations basically allow you to compute things like stresses much more accurately than if you try to pack in solid elements. Okay? So in this activity, what we're going to be doing is we're going to be learning how to incorporate beam and shell elements in Ansys in order to perform this kind of analysis. Okay? And so the geometry that I picked out to, which I've gotten from GrabCAD, I've linked the specific source there, is this bridge geometry. Okay? So if you notice from this bridge, all the geometrical features here can either be a shell or a beam. So we don't have anything where it's like a solid block of material where all 3 length scales are kind of the same. Okay? Like if you look at, for instance, if you look at this rod that's at the top here, that rod is really long, but it's not really wide and it's not really high. Okay? So we're going to replace that with the beam element. Similarly, if you look at the road, so they actually modeled the road in this CAD. This road is basically like a thin plate. So it's, really long in this dimension and really wide in that dimension. But if you look at the thickness, kind of in that direction, it's really small. So this is kind of the perfect candidate that we can use shell elements for. Okay? So even though, I call this an Ansys activity, it's really going to be a space claim activity because we're going to spend the majority of our time in space claim. So what we're going to be doing is we're going to be learning how to modify 3D geometries within space claim and replace things with shells and beams. Okay, so I know I've kind of put some disrespect on space claim at other times during this semester because I didn't know it had these capabilities. So please forgive me, space claim. You're not as useless as I thought you were. You're actually pretty good for these kinds of things. Okay, so now that we have that out of the way, we can hopefully work together. Okay. And so just a summary of the new things that we're going to do is we're going to learn how to open up a geometry in space claim first of all. Next, we're going to learn how to create shells using what's called a midsection operation. So I'll kind of explain what that means, when we get to it. Okay. Next, we're going to use what's called an extract operation to get beam geometries from basically slender segments with constant cross section. Okay. Then part 4, this is where we'll spend the majority of our time. So we'll learn how to clean up our new geometry in space claim. So that's that's going to be quite a process. And then finally, the only thing that we'll learn new in Ansys is to learn how to make manual connections, which are going to be really important as we're going to be fiddling with the geometry quite a bit. Okay. Okay. Oh, cool. So Chris says you can create 2D structures in space claim from internet images. So that's pretty cool. I'll have to look into that later on. Okay. Okay, so before we jump into Ansys or space claim, are there any questions on just kind of the motivation for this activity? Okay. All right, so if you have questions, just send them through the chat, or if you want to turn on your microphone, you can go ahead and do that, okay? But if there's no questions, I'm going to go ahead and trudge on, okay? So I've opened up Ansys here. This is kind of the screen that you see when you first open up Ansys. So what we're going to do is we're going to create an analysis type. So in this case, we're just doing a static simulation. So we're just going to take static structural and drag it over here, just like we usually do. Okay. Next, we need to load in our geometry. So I've uploaded the geometry to Titanium, so it should be an IGES file. You know, that person on GradCAD was gracious enough to you know, to create and share with us. Okay. So let's go ahead and import it. So let's right-click geometry, and then let's go import geometry. Okay. So I downloaded the file here. Okay. So the file should be called bridges.iges. Okay. So go ahead and download that to your computer and open it up, you know, in whatever location that you want. Okay. And then once you've imported geometry, we're going to edit this geometry in SpaceClaim. Okay. So you're going to right-click geometry, and then click Edit Geometry in SpaceClaim. Okay. So that's going to load up. Come on, SpaceClaim. Sure. So basically, we're going to be modifying our geometry in SpaceClaim. So once you've imported it, so you can import it basically in the same way that we've always done. So you right-click geometry from the workbench, you import your geometry. Okay. So the geometry I've uploaded onto Titanium. So it's you should see a file called truss bridge geometry. Okay. So once you've downloaded that, you can import it by right-clicking geometry here and going to import, and then browse for the file wherever you download it. And then once you've imported it, what you're going to do is you're going to right-click that geometry, and then you're going to click the button that says Edit Geometry in SpaceClaim. Right? So before we've edited geometries in Design Modeler, but this time we're going to edit it in SpaceClaim. Because SpaceClaim has some really nice features that will allow us to create shell and beam elements. Okay. Okay. So once you've opened up SpaceClaim, you should see something that looks like this. Okay. So here's our geometry. So you can kind of examine it just as if you would if this was in SolidWorks. Okay. I think this was created in SolidWorks first. So you can see right here we have a typical bridge where we have kind of the supporting sides of the bridge here. We have the road, which is in black, and then all the supporting beams. Okay. So we're going to be using shell and beam operations to basically transform this bridge, into something that we can actually, analyze. Okay? Okay. So the first thing that we're going to do is we're going to basically repair the geometry, right? So luckily luckily for this activity, this geometry is already coming in pretty clean. So the person who did this did a pretty good job in making sure everything was filled in and stuff like that. But if you're working with either your own CAD or some CAD that you got somewhere on the internet, you want to make sure that you start with basically as clean a geometry as you can. Okay. So our first step is we're going to go to this repair button in the top. Okay. So it should be kind of in the middle of your toolbar here, to the right of facets and to the left of prepare. Okay. And then the first button that we're going to click is the stitch button. Okay. So stitch, what it's going to do is it's basically going to look for like any kind of weird gaps that it can detect in your model, and then it's going to attempt to fill that in. Okay? Because those weird gaps are going to cause some problems with, first of all, it's going to cause some problems with meshing. Regardless if we try to do any shells and beams here. So this stitch is kind of a nice tool that SpaceClaim has developed to kind of automatically detect areas where there might be some trouble. So let's go ahead and click stitch. Okay. Right. So in this case, there's nothing that needs to be stitched. So you should see a message that pops up in the bottom here that says no areas need to be stitched. Okay. There's also the message right here that said there are no stitchable edges in this model. So that's a good thing. That means there's nothing that we need to fix. But in the case where you do have things where Ansys can stitch it, what's going to happen is that this green check mark right here is going to become basically clickable. So right now it's grayed out because there's nothing for us to fix or there's nothing for us to stitch. But in the case where you do have something, it would be kind of available right there. Okay. So the top cylinder has a gap between the supporting arcs. Oh, interesting. So it's did that show up when you did the stitch? Okay. Yeah, we'll fix that later. So kind of small gaps like that we'll fix after we did some beam stuff. But this is more talking about you know, if you have kind of hollowed out edges and stuff like that. But yeah, small things like that. Oh, I see what you mean. Yeah, there's a small gap right here. Usually that's okay. So if you have kind of things that are intersecting with each other, that's kind of what Stitch will look for. If you have or if you have solids that are hollow, because that'll cause an issue too. Yeah, but small gaps like this, we'll fix it up later. Yeah, good observation. Okay. Okay. Yeah, Space Claim can be a bit slow to load up. So if you're kind of, you know, if you're waiting for Space Claim, definitely let me know. Okay. So you know, when you open up Space Claim, you know, your geometry is going to be you know, loaded up right here. So the first thing that we want to do is we want to make sure that we're starting out with basically as clean a geometry as we can. Okay. So Space Claim has some nice automatic features that let you do that. So our first step will be going to the Repair tab, which is in the top right here. Okay. And then from the Repair tab, you're going to click Stitch. So what Stitch is going to do, Stitch is going to look for basically any areas where it kind of detects where it might see some kind of dubious geometry that's going to cause us problems down the line, mostly with meshing. And then it's going to basically attempt to automatically correct that. Okay? So, you know, a lot of the ones that, or a lot of the cases where Stitch will find cases, if you have kind of two solid parts that are basically running into each other and kind of overlapping. So in those cases, that can cause a lot of issues with meshing. So Stitch will try to basically clean that up. Okay? And so the next thing that we're going to do is we're going to click Gaps right here. Okay? So Gaps is kind of a similar thing where it tries to detect some kind of inaccuracies in the model. Okay? Okay. So in this case, we found something, right? So we you know, when we click Gaps, we see that we have this kind of small edge right here. So that can be fixed. So then let's go ahead and fix that. So to fix anything that the repair tool finds, we can go ahead and click this this green check mark here. Okay. Okay. So in this case, it says no problem areas were fixed, but that's okay because I know that this geometry will work out. So it's okay that it's like that. But normally, you know, when you click this repair tab and you go and click these things, they'll actually go and fix some stuff. But in this case, we're starting out with a pretty clean CAD file, so there's not much for us to do. But if in the case that you weren't, these are just some of the automatic tools that Space Claim will have to kind of help you out. Okay. Okay. Any questions on this, or are people still kind of catching up a little bit? Okay. Okay. So then now that we've cleaned up our model, or at least we tried our best to clean up the model, now we can actually start to create our shell elements. Okay. So to do that, we're going to go to the next tab over. So we're going to go to Prepare. Okay. So the Prepare basically gives you a lot of tools here for modifying your geometry to basically make it easier to you know, to work with later. Okay. So the first tool that we're going to use is called the midsection tool. Okay. So the midsection or the mid-surface tool is given by this button right here. So after you click Prepare, you can click mid-surface right here. Okay. And what this will do is that it'll allow you to basically you know, select places in your model where you want to make shells. Okay. So basically any geometry here which is relatively thin but has, you know, a good, you know, length and width, then we can turn it into a shell. Okay? So in this particular case, there are three locations where I'm going to create a shell. Okay? So the first one that's pretty obvious is going to be the road right here. So the road is literally a really thin plate, or at least the way that's modeled here. So let's turn this road into a shell. Okay? Because right now this road is technically a three-dimensional object, so you can see it has some thickness right here. Okay? But it's extremely small. Okay? So, you know, like we talked about before, when you have these three-dimensional objects that are actually really thin, the best thing to do would just be to simply just replace it with a two-dimensional object. Okay? So let's go ahead and do that. So after you click mid surface, you'll see that some surfaces will highlight in yellow when you mouse over it. So let's click the top of the road. Okay. So when you click the top of the road, it'll look like nothing happened. But then when you click the road again, basically what's going to happen is that what you did was you basically selected both sides of the road. Okay. So what happened was you clicked the top of the road first, then that selected it and made it invisible. Then you would click the bottom of the road, which completed the operation. And so what we're telling SpaceClaim here is that these are kind of two planes in our model that are parallel to each other, and they're extremely close. Let's replace these two parallel planes with a shell, because a shell is going to be a lot more convenient. Okay. So after you've selected the top and the bottom of the road with the mid-surface operation, you're going to go ahead and click this green check mark here. And then by clicking that, you're going to create your mid-surface. Okay. Okay. So then after you click this green check mark here, you can go ahead and click just anywhere else in your model. And what that's going to do is it's going to deselect it. And you can see, it's transparent, so it's a little bit hard to see. But what we've done is we've replaced that black road, which was a three-dimensional object and had just a tiny bit of thickness, with a two-dimensional object, which is basically just a rectangle that has no thickness. Okay. So what we've done is we've replaced that really thin three-dimensional structure with a two-dimensional structure, because that's that's going to be much better for us. Okay. Okay. So was everyone able to create a mid-surface from the road? Okay. Okay, so then now let's continue on with the mid surface, and then let's do it for the sides of the bridge. Okay, because these sides of the bridge, they're also relatively thin, as you can see from right here. So let's go ahead and create mid surfaces there. So let's go ahead and click. While we still have the mid surface selected, we're going to click this, and then we're going to click the back side. Okay, and so what you should see is that one side of the bridge will turn blue, and the other side will be green. Okay, so let's go ahead and click the check mark. And so once you click away, you can see that we've replaced the size of the bridge with this mid-surface operation. Okay? And then let's do the same for this guy right here. So we'll click once, click twice, green check mark, click away, and you can see now that we've replaced the road and the size of the bridge with shells. Okay? So instead of three-dimensional objects, we replaced them with two-dimensional ones, which have the same shape, but we've kind of eliminated that thinness dimension, which is going to give us trouble later on. Okay. Okay. So at this point, what you should have is you should have three shells in your model, one for the road and one for each of the sides of the bridge. Okay. So that's all there is to creating shells. So the only requirement for shells is that you have two kind of parallel planes that are next to each other. So a lot of your a lot of your geometries are going to have that that kind of feature. Okay? So that's for shells. So now let's make beams, because you can see we still have some geometries here that we can still work on. Okay? So we have this top beam right here, and we have all these bottom ones. Okay? So let's go ahead and create beams out of these. So the tool that we're going to use is this extract feature right here. Okay? So still working within the prepare tab. If we go over to the right of the toolbar, you should see kind of this, this whole section right here has to do with beams. But the only tool that we're going to use is extract. Okay? So you can see from the tooltip here, extract will create a beam from a solid where the solid has a constant cross section. Okay? So let's go ahead and click extract right here. Okay? And then what we're going to do is we're going to mouse over each of these structures here, and then just simply left click to create a beam. Okay? So let's start with the top here. And let's go ahead and left click. And you can see that solid cylinder has turned into just a one-dimensional line, where that one-dimensional line here is our beam. Okay? So then let's do that for all the bottom beams too. Okay? So all you have to do is make sure you have the extract tool selected, and then click on all of the beams. Okay? So there should be 8 of them overall. So you should have 1 up top, and then you should have 7 on the bottom. Okay. Let me orient myself. Okay. So we've turned our entire geometries into shells and beams. Okay. All right. So is everyone able to get to this part here and getting all the shells and beams? Okay. Great. All right. If you have any questions, definitely just stop me anytime. So I have the chat up right here, so you can chat anytime. Okay. So for beams, it's still going to be in the prepare section. It's just going to be on the right side here. Okay. So before we were working on mid surface, so then now we're going to work on beams. So the button that you want is extract right here. Okay. And then once you click extract, then you just click on all the beams in order to create beams out of them. Okay. So now that we've done that, you might think that we're done here, but you would be wrong. Okay, so we're not done, creating, working on this geometry, because if you fly around the model here, as people notice kind of at the beginning, we have some gaps, right? So if we look at kind of this beam right here, let me turn off this guy, not that one, that one. So you can hide different parts of your geometry by just clicking the check marks here on the left side. Okay. So you can see right here that this beam is not connected, or there's a gap between this beam and the bridge. Okay. So that's going to be a problem because in the three-dimensional geometry, that beam was supposed to be connected there, and it's supposed to help support the bridge from structural failure. So we need some way to basically connect this beam over to this this bridge here. Okay. And you can see that issue kind of persists kind of everywhere in the model, because if you look at kind of the supporting beams on the bottom like this beam is not connected to the bridge like it should be. Okay. So this happens pretty often when you're creating these shells and beams, because you're replacing a three-dimensional object with a one-dimensional one. There's going to be some gaps that show up just because you're kind of reducing the dimension of some sub features. Okay. But not to worry, Ansys SpaceClaim has a tool for this. Okay, so the tool for this is going to be called extend. Okay, so if you can read from the tooltip here, it says extend will extend surfaces, edges, or sketch curves so that they intersect with bodies. Okay, so let's go ahead and left click this extend tool. Okay, and then what we need to do is we need to basically raise the tolerance. Okay. Because what it's trying to do right now is it's going to be looking for any gaps that are 10 millimeters or less, and then if it can close that gap, then it's going to try to do so. But because this is a bridge, it's a fairly big geometry, so we're going to need to up our gap here. Okay? So instead of 10 millimeters, let's raise this to something a lot bigger. So let's change it to 50 millimeters. Okay? So once you've changed that dimension there, you can go ahead and hit enter. And then once you do that, then you should see that SpaceClaim will find places where it can connect. Okay. And so actually, let's make sure you have both of the bridge sides highlighted. Okay. Okay. So you should find about 8 areas here, and you should see highlighted in red are places where SpaceClaim can connect the beams to the bridge. Okay. So what SpaceClaim is basically saying is that, hey, I found this curve. It's kind of floating around in no man's land. But if I extend it a little bit further, then it can intersect with something, which is typically what we want. Okay? So after you hit the extend tool and you found that there are 8 different areas as indicated in the bottom here, you can go ahead and click this green check mark, and that'll perform the extend operation. Okay? So you can see once we've extended that, then this beam is now intersecting with this one. And then let's hit the green check mark again, and then that's going to connect those beams with the bridge on the left. Okay. So now we've extended some of the beams to intersect with the bridge. Okay. Oh, your axis can't spin. Yeah, sometimes it can be really easy to kind of get disoriented here. So and SpaceClaim, it's a CAD software, so it's relatively a bit heavy. So if it's locked a little bit, maybe just give it a little bit of time, and then you can hopefully spin it again. But yeah, it tends to happen sometimes. And in worst case, you can always just close the program and start it up again. Right. Yep. So that's the next thing. So so Jose brought up a great point. So you should, from doing that extend operation, you should only see about half the beams being extended over to the bridge. Okay. And if you're having trouble kind of seeing the beams, then what I've done is I basically turned off the road. So you can turn on and turn off the road by clicking this check mark on the left here. So my road ended up being solid 3, so I'm going to keep that turned off just for now. Okay. So kind of back to Jose's point. So Jose basically, noticed that not all the beams were properly connected, right? So even after running the extend operation, we still see a gap right here, right? And that's not good because we basically can't have any gaps in the model like this. And so the reason for this is that these beams are not properly aligned with the bridge. Okay, so let me actually zoom into this view right here. Okay, so I'm going to basically change the view such that it's centered on the z-axis. Okay, and if we look, we kind of zoom in on this beam right here. It's a bit tough to see, but you can see this this kind of little gray dot. Okay, so you can see that this gray dot, which represents our beam, right? It's not actually aligned with the bridge. Okay, so the extend tool failed because when we extend this, it doesn't actually hit anything. Okay, so what we need to do is we actually need to move this beam up a little bit so that it intersects with this edge. Okay, and we need to do that for I think 4 different beams. Okay. So this part is going to get a little bit tedious, but it's not too bad. So basically what we need to do is we need to move it. Okay, so we can move certain parts of our geometry from the design tab. Okay, so if you go to design right here, there will be a move operation that you'll see kind of in the middle here. So once you click this move, what you can do is you can select certain geometries and you can drag it up and drag it down, depending on how much that you want. But the problem here is that we don't know how much that we want to move it up or down. Like we can eyeball it as best as we can, but I think the better thing would be to actually measure it so that we can actually get a precise number for how much that we want to move this up. Okay. So in order to get that, we're going to need to use the measure tool. Okay. So the measure tool is going to be up at the top here. So let's go ahead and click measure. Okay. And then we're going to use this measure operator right here basically to measure the vertical distance between this beam and this bottom edge. Okay. So I'll go a bit slow here because it's kind of a lot of operations that we need to kind of do in succession. Right? So if you're kind of disoriented from all the zooming and the flying in, it's kind of good to kind of zoom out at this point, okay, just to kind of orient yourself. And then what we're going to need to do is we're going to need to focus on just one of the beams right here. Okay? So I'm going to focus first on this beam on the edge, where we can see, just by flying around that this beam is disconnected. Okay, so we know that we need to basically move this beam up so that it can be properly extended. Okay. Right. Yeah. So Chris's question is: the simplified beams are made by cutting out everything but the center of the cross section, running the complete length. That's correct. Yeah. Yeah. So basically, what Ansys Space Claim did was it once you click extract, it looks for something that has a constant cross sectional area, and basically it replaces that with the line that runs that area. And then as kind of a hidden variable, what it does is it saves kind of the cross sectional area just as a number. And it saves some indicator for the shape of the cross section, and it's going to use that as part of the analysis. But geometrically, it just replaces it basically with the line that runs the complete length. Okay, so then let's go and measure this. Okay, so to measure, we're going to left-click this measure tool right here. So what this will do is it'll allow us to measure stuff. So if you click something, it'll tell you stuff like that. So if you click if you click measure and then you click the beam, you'll see that the length of the beam is given by 635 millimeters. So that's about about 63% of a meter. Okay. But what we want is we want to measure the vertical distance between this beam and the bottom edge of this bridge here. Okay. So what you're going to do is you're going to select the beam with your left click. and then you're going to hold Control on your keyboard so that you can select multiple objects. And then you're going to left click, and you have to be really precise here. You're going to left click the bottom edge of this bridge right here. Okay. Right. And so what you are seeing right now is the distance in between these two. But we don't want just the raw distance. We want the vertical distance. And so once you've selected the beam, and then you've selected the bottom edge of the bridge right here, what you're going to do is you're going to go to the left right here, and then you're going to click this option for Show XYZ Vectors. Okay. And then once you do that, then you'll be able to see, the XYZ distance kind of between these two objects. Okay. So in this case, what we're looking for is the distance in the Y direction, because the Y direction is the one that's kind of straight up and down here. Okay. And we can see that we have a distance of 1.6221 millimeters apart from this beam up to this bottom edge right here. Okay. So what that tells us is that we need to move this beam up at least 1.6221 millimeters in order for this beam to kind of intersect with that edge. Okay. Okay. So then now let's take that information in our head, and then we'll use that to move. All right. So the question is, will each beam have a unique Y displacement? So yes, yes, it will. Yeah. So everyone's going to have something a little bit unique. So everyone's going to be a little bit different, just because the beams, they're all kind of slightly off centered by a little bit. Right? So this CAD wasn't as nice as kind of I was talking about earlier. So actually, when I was moving it earlier, I moved it up 0.3 millimeters. So you guys should have about 1.9221 if you're using the same model as me, or you're using the same site. Okay, so that's why we need to use the measure tool, because it's always going to be a little bit slightly different. So you need to make sure that you move it up kind of the proper amount. All right, so now that we have that number in our head, so for me that's 1.6221, but for you guys it might be something different. It might be a 1.9. Let's go back to the Design tab. So we'll go in the top here and click Design, and then we'll click this Move button right here, okay, which will allow us to move an object. Okay, make sure you click some white space just to make sure that you're you're not selecting anything else. So once you have the Move tool selected, go ahead and left click on your beam of choice, and then click the blue arrow to move it up in the Y direction. Okay. Right. And then what you want to do is you want to move it up just enough so that it's going to intersect with the beam, with the bridge. So you don't want to move it up too much, because otherwise that might kind of ruin kind of the kind of the point of the beams, which is kind of to rest at the bottom. So for me, I know that I needed to move it up at least 1.6221. So I'm going to move it up 1.63 millimeters. Okay. Okay. So once you've basically pulled up the blue arrow, you can enter something in your keyboard for that distance. Okay. So once you've entered your distance and you hit Enter, you've successfully moved your beam. So go ahead and click on some white space to deselect. Okay. And then once you've done that, let's go ahead and run the Extend tool again. So go back to the Prepare tab here in the top of Space Claim, and then click Extend. Okay. And then if you moved your beam properly and you moved it within the space of the bridge, you should see that the Extend tool has found two new areas where it can extend a beam to match your bridge. And those 2 points should correspond to the 2 points or the two ends of the beam that we just moved vertically. So if you run the Extend tool and you still don't see these, then you need to move your beam up just a tad more. Okay. So then once we do that, we can go ahead and click the green check mark. Hit it twice if you have to. And then what you can see now is that this beam is properly intersecting with the bridge, kind of as it should be doing. Okay. So I know that was kind of a lot of steps for something that was pretty tedious. So I kind of want to just take a second just to just to catch our breath. So was everyone able to successfully move their beam up and connect it to the bridge? Okay. All right. Yeah, it's a bit tedious. So yeah, it's kind of a lot of steps for, you know, and a lot of kind of small things. So, you know, definitely take your time. But you know, just you know, basically after we've done that first one, we're basically going to repeat the operation for the other 4. Okay. So if you were able to successfully extend that first beam right there, go ahead and do the same process for all the other beams that haven't extended. So there should be 3 more left, right? So if you're starting from this end, the second, the third, and the 6th beam are still not extended properly. So go ahead and do the same process for each of those beams. Okay. So I'm going to go ahead and do that. Right. So I'm going to go a bit faster here, just in the interest of time, but you can kind of see the process kind of from start to finish. Okay. All right, so the first thing is we need to measure. So go ahead and click measure, measure. Okay. Go ahead and click the beam that's not connected, hold Control, and then click the bottom edge right here. Okay. So you can see that we have a vertical distance of minus 1.4797. So that means I want to move this beam up by 1.8 millimeters. Okay. So now that I have that number in my head, let's go back to the Design tab and go ahead and click Move. Right. And then let's go ahead and click the beam and then move it up, and we're going to move it up 1.48, okay, which is just enough to kind of get it within within the plane of the bridge. Okay. So then now that we've performed that move, let's go back to Prepare and then hit Extend again, and you can see that we can properly extend this this beam to the bridge. Okay. All right, question. Yeah, so I'm moving it up. I'm moving it up kind of exactly as I can, but try to be as, you know, you can be approximate, but try to get it to as close to the distance as you can, because we basically want these beams to line up kind of exactly with this bottom edge. So we don't want them kind of floating up in this area right here. So basically, what I did was I basically rounded up to the second decimal place. So whatever distance that you measure, if you kind of round it up to the second decimal, just to make sure that you're kind of overlapping that area, then that should be pretty good. Okay, so then now let's do the process for the next beam. Okay, so let's go ahead and hit measure, measure. Okay. So let's do this beam and then hold Control and then hit the bottom edge right here. So you can see that distance is minus 1.8987 millimeters. So if we move it up by 1.9 millimeters, then that will do it. Okay. So now that we have that number in our head, let's go ahead and save that. Go ahead and click Design, and then Move, and then click this beam right here. Click and drag the blue arrow, and then we'll move it up 1.9. Okay. Right. And then once we do that, we can go ahead and hit Extend. You can see that we can extend this. Okay. And the last one that we need to do is this beam right here. Okay. So go ahead and click Measure, Measure. Okay. Click this beam, hold Control, hit the bottom edge. You can see this one's pretty close, so it's 0.4127 millimeters. So if we move it up just 0.42 millimeters, that should get us good to go. Okay. So go ahead and click Design, Move, click this beam, move it up, and we're just going to do 0.42. Okay. Then come back to Prepare, Extend, and you can see that, you know, we've extended these just fine. Okay. So then after you've worked with all the beams, you should see that they're extended pretty well. Okay. So all of them are connecting, you know, just as we want. Okay. Okay. So that takes care of all the beams. So all the beams are properly connected. So what that will allow us to do once we jump into Ansys, it will allow us to basically form our connections properly. Okay. Okay. So that takes care of all the beams, but we're not done quite yet because we still have our road. So we want to make sure our road is properly connected to our bridge. So if you turned off your road's visibility, you can go ahead and turn it back on. So go ahead and click this check mark here for solid 3. Okay. So you go ahead and look at your road. So you can see right now your road is kind of floating just in no man's land, right? So you can see it's kind of floating a little bit too high. And it's not connected to the left and the right sides. Okay, so we need to fix this. Okay, excuse me. So the first thing we need to do is basically the same thing that we did for the beams, is we need to move this road into the correct vertical position so that it aligns, well. Okay? So if we look back at the original geometry, then we know that the road is supposed to be resting on these kind of supporting beams right here. Okay? So let's move the road down such that it's basically going to be right on top of these supporting beams. Okay? So first thing, we need to find out how much we need to move it. So let's go back to the measure tool. So let's go ahead and hit measure and then measure. Okay. So then first let's click the road. So you should see it highlight in orange. Okay. And then same thing we did before, hold down Control and then left click the bottom edge here. Okay. And you can see that the road is 28.3735 millimeters above where we want it to be. So in this case, we're going to move it down. So I'm going to round this distance down. So I'm going to move it down 28.37 millimeters. Okay. Okay. So now that we have that, go ahead and click design, move, click the entire road. Be careful here that you don't click the edge of the road. Make sure you actually click the surface. Okay. And then let's go ahead and move it down. So once you move it down a little bit, you can enter a number. So I'm going to enter 28.37. And so what that did was it moved the road kind of all the way down there, okay? Right, so you can see now that the road is kind of resting on top of the supports, kind of how it should be, okay? And so then the last thing we need to do is we need to connect the road over to the sides of the bridge, okay? So to do that, we can go ahead and hit prepare, and then we can use our extend tool again. So, we've been using the extend tool to extend beams, but extends can also extend shells too. Okay, so go ahead and click extend. And you can see that it's found 2 extra areas here, which are basically the left and the right lateral surfaces of the road. So let me zoom out so you can see it. Okay. And so what the extend tool is going to do is that it's going to extend the road such that it's going to be overlapping with the bridge. Okay. So same thing as before. Let's go ahead and click the left check mark, or green check mark. Okay. And this time you only have to hit it once. And then the road will be properly extended to the edges of the bridge. Okay. So that was a lot of steps. Working with beams and shells. You'll have to spend quite a lot of time working on the geometry. But trust me, all the work will be worth it, because then in the end, your finite element simulation will run kind of a lot faster and a lot better than it would have done kind of without this. Okay. So later on in this activity, I'm going to ask you to perform this analysis with just regular solid elements. And if you can actually get it to run with tetrahedrons and hexes, I'll be pretty impressed, because I couldn't get it to run. But you can see when we do this in terms of shells and beams, simulating this is going to be really simple, because we're going to end up with something with not that many elements, but we'll still be able to get accurate results because of the shells and the beams. Okay? So I know that it's it takes kind of a lot, and there's kind of a lot of steps that goes into processing it. So I'm recording this lecture right now, so you can use this kind of as a you can kind of look back on it and to kind of help you prepare your geometry. Okay, are there any questions on this? We're basically done with space claims, so we're going to be going into Ansys Mechanical after this. But any questions before we do that? Okay. All right, so there's no more questions. Let's go ahead and exit here. Okay. All right, so the question is it possible to add assemblies to SpaceClaim, or is there a certain file type that should be uploaded? So you should be able to do assemblies from SolidWorks, but you can't upload the SolidWorks assembly file. So you have to convert it to usually an IGES file works pretty well if you're doing SolidWorks parts. So if you save your assembly as an IGES, then you should be able to import that into Ansys. Mm-hmm. Okay. All right. So the question is, how much computational time would you estimate that this saves versus 3D everything? It really depends. For this case where you have like very thin structures, I would say that at least reduces it by a factor of 80%, I would say. Because if you try to do this with 3D elements, what you'll see is that you'll have nodes that are in the order of like 30,000s. I think with this, your node count will be somewhere in like the 2,000s or 3,000s or 4,000, 5,000s. Yeah, it's pretty significant. Yeah. So it's definitely a lot. I'm not going to shy away from it. It's a lot of work to work on the geometries like this to get it to shells and beams. But all that work is really worth it. Especially if your geometry has a lot of these slender structures, because you're going to be running fits trying to mesh that thing usually if you don't do this. Okay. So now that we're done in space claim, let's open up Ansys Mechanical. So let's go ahead and double click model. I should have done this while answering questions. I feel like I did that during the last activity too, but it's okay. Okay. So kind of the last big step that we have to do, kind of that's kind of beyond what we usually do of meshing and boundary conditions, is that we have to define the connections. Okay? So if you remember, when we tackle Ansys projects with multiple parts or multiple parts of the geometry, we need to define how those parts are going to interact with each other. Okay? So in this case, every single shell and every single beam that we created was a separate entity, was a separate part. So basically, what we need to do is we need to define how those parts are going to interact with each other. And so since we created all of these shells and beams manually, Ansys doesn't really know what to do with those things yet. So we basically need to tell it how to do that. Okay. Okay. So here we have our after you open up Ansys Mechanical. So mine opened up relatively quickly, but yours still might be going. But since we have just 15 minutes left, I'm gonna trudge ahead. But you guys can can catch up when you can. Okay. So first thing we'll do is that, this is kind of an artifact of, grabbing this geometry from GrabCAD. We have this mysterious cis surface right here. Okay. So if you remember, this was the part of the model that we couldn't repair. So we don't actually need it in here because it's just an artifact. So let's go ahead and right click this. We can actually delete it, but let's at least just suppress it so that we don't have to see it. Okay. So you can see right here, we have our shell for the road. We have our shells for the size of the bridge, and then we have all of our beams. Okay. So right now, there are no connections here. So there's if you go to the connections tab right here, you can see that there's nothing here, which is not good because we should have some connections here between all these different parts. Okay. So first thing we're going to need to do is we're going to need to define those connections. Okay. So to create a manual connection, so this is the first time we'll be doing this. So you're going to right click on connections, and then you're going to go to insert, and then you're going to insert a manual contact region. Okay. So let's go ahead and do that. Okay. So then once you've done that, you're going to come up to a menu right here on the bottom left that'll basically tell you to define what's called the contact region and then the target region. Okay. So basically we need to connect connect all of the parts kind of where they need to go. Okay. So if you look at the PDF, I basically tell you kind of 3 categories of connections that we need to make. Okay. So the first thing that we need to connect are the ends of the beams to the corresponding side of the bridge. Okay. So if you kind of zoom in on your geometry here, right, you should see that at the end of each beam, we have these convenient little white squares that kind of tell us the end. So basically what we need to do is we need to connect these points to the surface of the bridge. Okay? And so we need to do that. We need to make one connection for the left side and then another connection for the right side. Okay? So let's do the left side first. So first, let's select all these little squares right here. So this is going to be precision mouse clicking. Right? So what you're going to do is you're going to left click one of these, the ends of the beam. So left click that little white square that appears there. So it should turn green. Okay. And then what you're going to do is you're going to hold Control on your keyboard, and then click all the other sides of the beam right here. Okay. So go slow, if you if you need to. This is not a race. If you don't have the little white squares, then see if you can select the ends of the beam. So you might have to turn on Vertex Mode right here, because right now it's kind of under Smart Select. So basically, selects just kind of the thing that it sees. But if you don't have those white squares, you can click this Vertex Mode, where you can click kind of the end vertices of those beams. Yeah, but you want to get the ends of the beams kind of as much as you want. Yeah, so it might yeah, if you do Vertex Mode, you might be able to work a little bit faster because yeah, I messed up. Yeah, let's do that. Let me turn to Vertex Mode. Yes. Thank you, Scott. Very well timed mistake there. So go ahead and turn on Vertex Mode, and then we can select all these points more easily. Okay. So now we'll be forced to select these vertices. Okay. So this last one here is actually not a beam, so that's just the end of the road. So you should be selecting seven of them down here. So 1, 2, 3, 4, 5, 6, 7. Okay, and then we can't forget our one on the top. Okay, so let's go ahead and click this one on the top. So once you have all 8 of those selected, go ahead and click Contact and then hit Apply. Okay, and then once you do that, you should see this this change. So you should see the contact should be 8 vertices here. Okay, and then the target is going to be the thing that we want to bond it to. So the thing we want to bond it to is actually the size of the bridge. Okay, so the side of the bridge is a surface. So let's go ahead and change this to face mode right here. Okay, so then now they're in face mode, go ahead and select this entire left side of the bridge. Okay, and then go ahead and hit Apply. Okay, so let me move the chat. So after you've selected the 8 vertices as the contact and then the face as the target, then you should see the results of your connection on the right here. Okay? So on the top screen right here, you can zoom in and out. You should see the 8 vertices of your beams, and in the bottom here, you should see what you're bonding it to, which is the side of the bridge surface. Okay? So that's the left side of the bridge. So we need to do the same thing on the right. So go ahead and rotate your camera, and let's do the same thing. Right? So let's start down here. So we need to create another manual contact zone. So right-click Contacts, same things before, hit Insert, and then we're going to insert a manual contact region. Okay. So then let's do the same thing as before. So let's select all the vertices on the other side of the bridge. So make sure you're doing the other side, so you're not selecting the same things for both sides. Okay. So let's follow Scott's advice. So let's go ahead and click Vertex Mode, and then let's select all these points here. Okay. And then we'll not forget the one at the top. So let's make sure we have that. So once we've clicked all 8, we can go ahead and hit Apply, and we can see we have 8 vertices there. Okay. Once we have the vertices, we're going to go ahead and change to face select mode, and then click the other side of the bridge. Go ahead and hit Apply. Okay. And so with that, all of our beams are going to be connected to the bridge. Okay. So all of our beams are good to go. Okay. Okay. Any questions on that, creating the manual connections? Okay. So that's the first category of connections that we need to make. So if we go back to the PDF, we can see that the other category of connections that we need to make is we need to connect the lateral edges of the roads to the side of the bridge. Okay? So this one's tricky because what we need to do is we need to connect this edge of the road right here over to this side of the bridge. Okay. So it's tricky because the sides of this road are basically going to be coinciding with, they basically kind of coincides with the edge of the bridge. Okay. So it's very easy to actually select the wrong edge right here. Okay. And so in order to make sure that we select the correct surface, what we're going to do is we're going to make use of the hide feature. Okay. So first, I'm going to bond this this left side of the road with the left side of the bridge. Okay. So in order to select that edge of the road, I need to hide this this part of the bridge just so I can properly select that edge. Okay. So let's go ahead. So now that we know that solid 2 is this side of the bridge right here, let's go ahead and hide it. So to hide a solid, we can right-click this, and we can go click on Hide Body. Okay. So that just temporarily hides that body for now, just to make sure that we can select this. Okay. So let's go ahead and create another contact region. So go ahead and right-click Contacts, click Insert, and then click Manual Contact Region, just like we did before. Okay. And then we want to select this edge of the bridge right here. Okay. So make sure you're on Edge Select mode. So go ahead and hit this, or you can do Control E for the shortcut. Right. So once you do that, go ahead and select this edge right here. Okay. And go ahead and click Apply onto that edge. Okay. So now that we've properly selected that edge, now we can properly bond it together with the surface. So let's go back to our bridge surface and let's unhide it. Okay. So go back to your geometry up here, and then to the body that you've hidden, and you can tell which one it is because the green check mark here is grayed out. Go ahead and click Show Body. Okay. And then once you do that, go back to the contact that you were creating before. So under Contacts, go to Bonded right here, and then we need to set the target for this bond. Okay. And so our target's going to be the same. It's going to be the entire surface of that bridge. So go ahead and click the face. Okay. Make sure you're in Face Select mode. Click the left side of the bridge, and then hit Apply. Okay. And so what we've done is we've bonded the left side of this road to the bridge. Okay. And then we're going to do the same thing on the right here. Okay. So let's do it again. So let's go ahead and right-click this, Insert Manual Contact Region. Okay. And then let's take this side of the bridge and let's hide it so that we can, properly select that edge. Okay. So now that we've hidden that, make sure you're on Edge Select mode. Click this left side of the bridge right here. Go back to our contact, hit Apply. Okay. So now we've properly selected that edge. So now let's show this surface again. Okay. Make sure we're on Face Select mode. Go and select that face. Go back to here, select the face again, hit Apply. Okay. So now our road is properly bonded to the bridge. Okay. So you should have 4 contact regions now. So you should have 1 contact region for the left side of the bridge and all of the ends of the beam, 1 for the right side of the bridge and all of the ends of the beams. Then you should have 1 contact region for the left side of the road and the left side of the bridge. And then you should have another contact between the right side of the road and the right bridge. Okay. All right. Any questions on that? Okay. So then if we go back to the PDF, we'll see that we have 1 more contact region that we need to do. And that is we need to connect the road to all 7 supporting beams on the bottom. Okay. So this one's relatively simple. So we don't need to hide anything. Okay. So let's go ahead and right-click Contacts, and then create another manual contact region. Okay. And so the first thing that we'll select is the road. So make sure that you're in Face Select mode. Okay. So let's go ahead and select the entire road, and then hit Apply. Okay. So you can see that we have 1 face there. And then for the beams, make sure you're on Edge Select mode, and then use Control and click to select all the beams on the bottom. Okay. So you should have 7 beams. Okay. All right. And so you should see that we've created this contact. But if you did it in this order, what you should see is that you have this question mark here, so it doesn't like this. And so what that means is that we need to reverse the order of this contact here. So we need to make the 7 edges or the 7 beams as the contact, and then the target to be the road. Okay? I'm actually not sure why this is an issue right here, but it's it could happen. Okay. So if that's the case, you can just reverse it. So go ahead and make your contact equal to the 7 beams there. Okay. And then for the target, make that the road. Okay. All right. And so with that, we have our 5 contact regions that properly bond this this structure together. Okay. So now all the beams will be connected to everything it should be connected to, and the road should be connected to everything it needs to be connected to. Okay. All right. Any questions on that? Okay. And so from here, that's basically all the new stuff that you need to do. So basically, you can mesh this and apply boundary conditions kind of exactly the same way as we've done before. Okay. So let's just since we don't have that much time left, I'll just kind of do a basic setup for you. Okay. So go ahead and right-click Mesh, and then just without inputting any settings, we can go ahead and click Generate Mesh. Okay. Right. Right. So you should see the mesh being created here. Okay. And you can see we have a pretty cheap mesh. So I mean, we didn't change the element size, but you can see that we have the order of 793 nodes and 600 elements. So it's going to be pretty cheap. Okay. Right. So so the question is the process of the height shifts and the extensions shouldn't affect the original moment of inertia. So it will affect it a little bit, but the hope is that when you make these little small adjustments, they're so small compared to the the total scale of the geometry, then it's not going to make a significant effect. So we make small adjustments just to kind of make our simulation work. But that's why I wanted to keep those adjustments as small as we could, just to make sure that they don't affect the physics all that much. Yeah. Mm-hmm. Okay. So before we go, actually, I want to run a simulation. Right. Yeah, it's a good compromise. I want to show you kind of a shortcut that a lot of you probably have figured out already. So if you want to kind of globally change the edge size or the element size, you don't need to make actual sizing objects. So if you left-click Mesh right here, you can just go ahead and click this this element size. So you can see the default here is 93.175. Okay, so let's refine this. So let's cut it in about half. So then let's go ahead and click 50 millimeters, and let's go ahead and click Generate Mesh. Okay. Right, so Damien's question is, would we have to quantitatively justify doing this by comparing the 3D model method for most cases? Usually no. So usually if you do a shell and the beam model, then usually and you're careful, you're kind of careful about making the small adjustments, then you don't have to run the 3D model. Because the point of running, because the point of making the shells and the beams is so that you don't have to do the 3D model to begin with. Okay. All right, so Daniel's question, why did my model turn to solids when I generated the mesh? That's a good question. I've never seen that before. So maybe we'll talk offline, and then we'll. Oh, yours did too. Okay. When you check the element statistics here, is that do you guys see kind of relatively the same? So you change your element size to about 50 millimeters. Do you get this relatively about 1,761 nodes? Okay. Got it. Okay, so I think what you guys are probably seeing is just a rendering thing. So it's I think you guys are still using shell and beams, but I think there's a visual setting where it's just displaying them as solid bodies. But if you're getting the same number of nodes and elements, then you should be good to go. So later on in this activity, when you try to do it with solids, you'll notice that there's a huge difference between this and that. Okay. Right, so we've basically run out of time. So, you should be able to take it here for the rest of the activity, because the rest of the activity, applies things, as we know them before. So I want you to apply the mesh. Oh, 800 nodes, that's good. The less nodes, the better. That means it's going to be cheaper. Yeah. So problem 3, you're going to apply loads and constraints. So that's exactly the same before. Here, problem 4, I want you to print out some of your results. Okay. And then problem 5, what I want you to do is I want you to attempt to try to do this with solid elements. So do none of the beam and shell stuff. Basically create a whole new project, and don't do anything to geometry, and try to get this to run. And what you'll see is that you might end up very frustrated, just like I was. So if you can get it to run, I'm going to be pretty impressed, because at least if you can get to run with the student version, I'll be pretty impressed, because I could not get it to run. Right. Okay, so that's it with this activity. So I've included a couple of screenshots of my results just so you guys can kind of check. But you guys can go ahead and start working on that. So if you have questions on this, definitely let me know, and then we'll sign off from here. Okay. Right. So the question is, since this is not a 3D object mesh, would making it a very refined mesh still be computed quickly? So it's if you make a very refined mesh with this, and the element count is still pretty small, it should be computed pretty quickly. So the cost is basically determined by how many nodes and how many elements you have here. So as long as these are pretty small, then you should be able to compute it pretty quickly. Yep. Okay, so for my model, I picked a global element size of 50 millimeters, and then I have 1,761 nodes, and then 1,225 elements. Yeah, so it might not be exactly the same, but it should be, within the same ballpark, within like maybe 50 elements here and there. So you should be something pretty close. Okay, so we're out of time today. So have a great weekend, everyone. Everyone, please stay safe and stay healthy. And I'll see you guys next week. Right? So I'll stick around if you guys have some more questions, but if not, you guys are free to go. Yes. So when I did my displacement constraint, I did it in terms of components. And most of the time, you want to do things in terms of components, just because it's a bit easier or easier to visualize. So let me share my screen again. Yep. So when you do the displacement constraint, okay, and let's just select this side of the bridge. Doesn't really matter. Oh no, not that. I wanted edge. Edge. Okay. Yeah, so if you define by components, so mine's by default, but for others it might not be by default. Okay, I basically just set this to 0, and then that's it. Mm-hmm. Mm-hmm.